Thank you. We'll go to the Q&A session. We have received 2 or 3 questions. The first question for Guillaume. Why is offline learning safe as opposed to learning in operation?
Okay, yes. No, it's a very interesting question. I understand it relates to the part of my presentation. We've put this first to say we are not saying that offline learning is de facto safe. Of course, you need to do all the work on learning assurance, tackle all the problematic that were just shown by Jean-Louis. All of that needs to be done to make it safe, of course. So it's not because it's offline that it's safe. Now, offline is safer and is more bounded in the sense that today we would not be able, in fact, to consider models that would carry on learning in operations simply from a regulatory perspective. It's not linked to AI. Today, we have a Part 21 in initial airworthiness, just to take one domain as an example. We cannot certify one aircraft and then have, let's say, 10 that are one product, 10 aircraft flying, and 10 are kind of implementing their own functions over time by learning. This is totally against the principles we have today. So there is no, let's say, limitation to think about the issues. Of course, first, there is in non-safety related application, there is surely a lot of potential for continuous learning. I think predictive maintenance, for instance, there is a lot of applications possible. But if we are thinking safety related, for now, it's a barrier, it's a boundary, but it doesn't mean freezing a model forever. Of course, we still have the capability of major changes to a product to recertify in an efficient way a model that possibly, I don't know, expressed something that is not acceptable in operations. An incident was raised, an occurrence. Based on the occurrence, why not updating the model? Of course, we should. And then we recertify the model. So the point is, we will not let something learn by itself. We will freeze it, but of course, with the potential of updating it whenever necessary for a safety purpose.
Okay, we have a question about means of compliance, but I will complete the question. In fact, means of compliance are what is in your concept paper. It will become means of compliance of the regulation or the AMC and GM. But today, in your concept paper, then you introduce the W life cycle in comparison to the V life cycle. I have a question about the impact on the certification effort it will bring. And it's a question for industry too. What do you think, what is the impact on the level of certification, the level of effort of the industry to comply with the new W compared to the fundamental, I would say, software argument or component with DO 178? What is the increase at such a new guidance?
It's also a very good question. I would say first, means of compliance. In the concept paper, we have objectives and we have anticipated means of compliance. So we are not enforcing a means of compliance over another. Actually, we gave a shape of W again based on the understanding of the adaptation of the process to learning processes, of the existing assurance processes to learning. And then we tried, I mean, we had the W shape, we had certain boxes, and then we tried to put shape to, by working in particular with Idelin in the first IPCs, on what it requires actually to meet such an objective. So the anticipated means of compliance are not forever there. Of course, through the rulemaking process I was showing, through the use and reference to existing or standards to be published, of course, we will use means of compliance that are consensus and not enforced by EASA. Very important to mention. Now, what it takes. The way we see the W, it's creating a bit of a layer in between system and traditional software hardware. We have what we call the constituent layer. Now there is a number of elements to tackle, in particular data management, learning management, and all the aspects, again, that Jean-Louis was highlighting. And I agree, and I subscribe to what Jean-Louis was saying. We have to work on novel type of means of compliance compared to the existing approaches, in particular for stability, robustness, generalization guarantees. And that's why we launched MLIP, to have at least a view. It's not the end. I don't claim that the MNIP report has all the answers, but it has a number of answers, at least to show case by case what can be done in different and numerous type of use cases, because the dimensionality of the input space changes everything. You have to consider different means of compliance for different type of use cases. And that's exactly what we now inherit and will process through the concept paper update, but also through the rulemaking to find the right level of means of compliance.
I will ask the question to industry, because today, Hugo, for instance, you are in certification with EASA, then you start to apply the main principle of the concept paper, even it is not finalized mock means of compliance. Then for you, what is how is the work? How your difficulties? What do you think?
Yeah, so of course, at the moment, the effort required to do the learning assurance and the double-shape process is extremely high. We are, of course, as a company, starting to implement these processes and to become a design organization. We already have quite a high effort to meet the DO 178 and DO 254 processes, but those standards exist. We have people with experience on them. So we can work through that, and when talking with the authority, the answers are more straightforward. The problem with the learning assurance is these processes don't exist. The standardization is not there. So the back and forth between the authority and the industry is at the moment very high. But like our previous CEO used to say, if it's easy to do, it's not worth doing. So we just have to do it.
Gary?
I share a lot what Hugo said there. I mean, in the real world, when you get down to it, we need the standard. We need the ARP 6983, ED 324. It's very hard without the standard at the minute, because we face the EASA concept paper for all its good intentions. My experience to date has been the biggest hurdle to solve is the safety one. Trying to agree between two parties in a CRE, what is the safety effect? Or I call it reliance. What is it? Because we can oscillate between, well, it's going to be catastrophic and everyone's going to die, to actually it's minor. So there's different opinions. So, and then there's the time. EASA is very busy. We're very busy at our OEM, and it's getting that opportunity to sit down. So without the standard, and obviously the rulemaking that EASA is going to do will overlap in the AMC, the standard, because there'll be even, they'll have their own expectations that are not in the standard, like ethics, for instance. We're not covering that, nor are we covering security. We're not even covering unsupervised, which EASA is doing to minor. But yeah, the experience for me is just agreeing the reliance. Because if you don't agree the reliance, you can't start the development assurance.
Okay, thank you, Gary. I think Jean-Louis will tell us robustness also. There is a lot of things to do.
Yes, the point about the W cycle is it's normal, because you have completely changed the way you develop. You have replaced the brain by the data. And so it's normal that you have this training phase, which is very important, which is the design phase, in fact, but which is very different from the fact of refining requirements. And so it's normal that you have this W cycle. Now, on the global point of view about certification, we have not yet experienced the EASA guidelines, because we are working especially on the military for deep networks. And so we are, for the moment, just trying to make robust networks with classical techniques of robustness, data augmentations, and so on. But I invite you to look at an RTS paper of people who try to apply the EASA guidelines. It's very interesting. I had the chance to be the chairman of the session in RTS who presented this paper, and so I looked carefully at this paper. And what this paper says, in fact, if you look at it carefully, is that the EASA is asking the good questions. It's a bit what I said in my presentation.
The objective.
They ask the good question, but the state of the art cannot yet answer to these good questions. So today we are a bit blocked.
Interesting.
If I may put a bit of hope also in in the balance. Now, fully agree with your statement of concern, Jean-Louis, but definitely in a certification project, we have also a pragmatic approach. So that's why I was saying level 1 is at hand. Deploying, let's say, a neural network with minor and possibly major, let's see, but at least with minor safety impact, we will manage it because we have other mitigations. And let's say AI has not changed, or machine learning has not changed the view that you still have to deal with your safety assessment with the notion of architecture of the system, with all the mitigations in place. The human end user is a strong mitigation at level 1, which starts to be a bit more difficult at level 2, and it will be kind of inexistent at level 3. So you see the ramping up in levels is super important in this discussion here, because at level 3, we will need actually this total reliance on the system, and that's a different case.
I have a complementary question, because Baptiste told us that we are very far from DAL-A. Then today I've seen some DAL-C in some presentation, but what will be achievable next year? Because next year you say that maybe there will be one certification on the first question, on the first application. What will be the level of this first certification, and how do you foresee DAL-C or DAL-E in the future, in the roadmap? Where do you see, at what time you see that?
Yeah, the horizon is, of course, it's crystal ball thinking here, and any project, certification project takes its time. So we anticipate level 1 minor failure contribution, let's say DAL-D next year. That's what we can anticipate based on what we have in the pipeline. After ramping up to DAL-C raises exactly the questions on generalization aspects. But we are looking actually at the same topics in the DAL-D, because we have applicants that are, as Hugo was saying, that are ready to go a bit beyond the, let's say, the demonstration sometimes. And that's helpful for us also to see the measure of what is feasible. So we can ramp up without going too far in the risk and the safety risk. That's very important.
How many applications you have on the table today at IASA from industry?
Well, same thing, difficult to trade secrets, but it's a dozen actually where we are right now.
Okay. I have a final question, which is not really technical, but it is: will the business master AI, or will AI master the business? Notably, why the fear of being replaced by AI was never expressed in the conference?
I think I will let it to the colleagues, but just answering the last point. Why? Because I think I could express it rapidly through my presentation, but we could really look at it. We have this human-centric approach, meaning we don't want to replace a human, but we have operations coming without human in the future. And I'm thinking drones delivery, use space. We won't put, let's say, an air traffic controller in the use space. That's not the concept that we see popping up right now. Therefore, we have to also look at the, let's say, the cases where the human will not be there. But the approach, the whole overall approach, and what we see with our industry is not to replace the human by all means, and to keep this human control and at least in operational time as far as possible. When there is no control in the operational time, the level 3 concept, and more to come next year, will be human-centric in the sense that the development will be fully mastered, the operational envelope, all the uncertainties will be managed kind of upfront, a bit what was presented by Baptiste before. If you can't manage your contingency and uncertainty, you don't release an application. We don't call it autonomous again, we call it advanced automation. So fully automated won't make the case if it's not managed from a safety perspective, uncertainty, contingency, etc.
Okay, and on the first part of the question, you have...
Sorry, you'll have to remind me, what was the first part?
The fact is, will the business master AI, or AI master the business?
Okay. I think the answer on that is, or the way I think about that goes back to how humanity dealt with all technological advances. When the industrialization started to happen, lots of people lost their way of living. Lots of people had to change how to work, how to live. There was extreme suffering, but as humanity learned to use these tools, we just kept growing. And I think with AI, it's going to be similar. Maybe I'm naive, I don't know. But I think if policymakers can adapt to it, there should be a way to ensure that people that are suddenly affected and losing jobs because of introduction of AI have a way to easily find jobs in a different place or have some welfare protection. But I think lots of different opportunities will be created. I mean, if we think about pilots, for example, which may seem more affected through these talks, this is mostly driven by the fact that there are going to be more and more aircraft on the air. This same concern happened when we lost the in-flight engineer or when we lost the navigator on the cockpit. When we lose the co-pilot, the same concern will happen, but there will be more pilots, I guess. But yeah, I think that's at least my approach of thinking about that.
Thank you. Additional comment? No?
Yeah, it's a good point. I mean, if we imagine we go to single pilot operations, then ML with a implementation opportunity could become the substitute and bring you up to the same level of safety. And when I say single pilot, it could be you have two pilots on board, but one pilot decides to go on to have a coffee break, a rest. If you're doing long haul flights and you're traveling in a cruise for 8 hours, then why have two pilots in the cockpit? Why not have a pilot to have a rest time? You could have 4 hours sleep. One pilot stays in the cockpit. So long as you have the mechanism to alert the pilot sleeping to get back to the cockpit within a reasonable time frame, you know, you have the means to equalize the safety. But I would argue that when people say that, well, that's not safe, I would say, well, think about when you come to land. You've had two pilots who've probably been flying that aircraft for 10 hours, 8 of it in cruise, happen to be both awake, and they're going into landing. Is landing not a dangerous time? Takeoff and landing are the most dangerous times. So I think actually when we think about it holistically, we can imagine that there's actually a benefit to allow a pilot rest time in a long haul flight. And you can use ML as an opportunity to support the aircraft as much as you can use software. Again, it depends on the need. You don't have to use ML, but it could actually be the problem solver, the selling point. Thank you.
Thank you. I think it's time to close. We have only 10 minutes. We are 10 minutes late. Thank you very much. Thank you to the speaker. We can what you have done.